Muito bom dia a todos, sejam muito bem-vindos. O meu nome é Mónica Ribeiro, do Departamento Comercial da Danysoft e responsável por Portugal. Antes de mais, quero agradecer a vossa presença e vamos então dar início ao início do workshop técnico de modernização de código com Intel Parallel Studio, com o meu colega Carlos. Carlos, pass to you.
Bom dia, tudo bom? Meu nome é Carlos Garcia. É um prazer para mim começar este workshop intitulado Modernizar seu código com Intel Parallel Studio. Eu vou fazer a apresentação deste workshop ao longo dos 3 dias em 2 idiomas, em português e em inglês. Bem, então vamos a começar a parte em inglês. Well, in this workshop, I will talk about the introduction of Parallel Studio Suite. Basically, I have divided this workshop in 3 days. The first day corresponds with a brief introduction of Parallel Suite Studio of the 2020 version and what are the main novelties of this version nowadays. The second day, that we will tomorrow, we will talk about some performance tools in order to find out what are the inefficiencies in the code and try to solve in order to increase the performance. Finally, in the last day, the third day, we'll talk about another profiling tool of Intel available in the Parallel Studio Suite, the VTune, and also some introduction of the new paradigm promoted by Intel, known as 1AP. That corresponds one model of how to improve the performance of your coding because you are coding in one scenario in this one API, and after that, this code can be run in different type of architectures such as CPUs, GPUs, and FPGA of Intel, all of them. Well, so I will begin with this introduction to the first day, and I will talk about how what performs with Intel Parallel Studio 2020. So in this first slide, we're going to present the main advantage of using Parallel Studio Suite. Intel's Parallel Studio is an Intel suite that allows to build, modernize, and develop applications in order to improve performance in high-performance architecture that can be found from APC to another type of architecture such as cloud or even in artificial intelligence scenarios. In these suites, we can find some type of tools which help us for the developing tasks and also allows to modernize codes in order to improve the parallel performance, exploiting different levels of parallelism. It is also available graphical tools in order to improve the performance and also to find about bottlenecks and possible inefficiencies in the code. Currently, it is support the high-level language, for example, C, C++, Fortran, also profiling tools, and some optimized libraries which efficiently exploit the different level of parallelism existing nowadays in the current processor. It is supported the main operating systems such as Windows, Linux, and MacOS, and we can try to answer this question of who needs this product, why it is important, and focus on who is or for what is interesting too. I can answer that will be interesting for developers and software development scientists, especially from high volume data application, HPC in general, and also artificial intelligence related application. Why it is important? Well, this product is related to the sophistication of general purpose desktop processor, such Xeon processor. This type of processor have several levels of parallelism. For example, there are multi-cores. Inside the multi-cores, you can exploit data parallelism by means of vector exploitation and so on. So the main idea is that with this suite, this suite helps you to modernize the code efficiently and also optimize your application for actually platform and from the future. And one of the idea also is that it's totally updated with in the standards, the compiler standards and the rest of the library. I would like to finalize this first slide with the idea also that you can download this code because there is a trial version and you can download and test it in this link. Well, in this second slide, I showed you a brief introduction about the main advantage offering by the Parallel Studio Suite for the construction of parallel applications. From business that came from clouds, and HPC scenario, and also in artificial intelligence area. The first point to consider is the ability of the developed suite to exploit the different levels of parallelism that are available nowadays, from vectorization, multi-cores or multi-threading to the multi-cores, and also another type of optimization focused on the memory hierarchy. Also, it is interesting to note that this suite also accelerates the performance in other type of application, such as artificial intelligence, by providing an optimized distribution of Python language. I would like to note that this Python is actually supported by most of the compiling the compiling companies, and also is very extended between the developers. So would be a good idea to try to use this Python library in order to improve performance on Intel architecture. Its aspect also will increase the productivity, taking into account all the level of parallelism that was mentioned before, and improvements are also seen in another scenarios such as network, in a cloud, for example, in terms of the communication by means of the library such as MPI, by messages that are passing through the different nodes, and also another type of accelerators such as GPUs and so on. And finally, another advantage of using these suites can be found by the developer community and also in the support of technical questions. Well, what are the most novelties in this 2020 version? Among the main innovation of this suite, we can find on one hand the acceleration of applications related with artificial intelligence, especially who in the inference phase, thanks to the support of the new instruction, that vector neural instruction, that allowing the computation with reduced precision incorporate in the last cascade platform or processors. It's also interesting that this suite also incorporates the improvements related with the support of extended persistent memory up to 512 gigabytes, and also is supported by profiler tools as VTune amplifier that I will deep in the second and the third day of this workshop. In addition, some compilers such C++ have full support of the new features related with the C++ 15, and also is beginning to incorporate some of the features of C++ 20. Another improvements can be seen because coarse grain profiling is also available in the VTune, and it's actually supported over the Amazon cloud, high bandwidth communication by means of MPI, and also it's added the support of the new operating system in this Amazon cloud known as Amazon Linux 2. Well, in this slide, I try to show an image of the main version of the Intel Parallel Studio. It includes the basic edition called Composer Edition, which is focused on building an application. So it includes basically compiler and libraries. The most the well-known compiler C, C++, and Fortran, and also another libraries which are optimized internally by the exploitation of the different level of parallelisms, such as OpenMP or multi-threading and vectorization capabilities. In addition, the professional edition that also includes the Composer edition includes some analysis tools which allows us, for a developer, for example, to check where are the inefficiencies in the codes. And this part of analyzing tools will be shown in the second day, particularly the VTune and the Intel advisors. The Intel advisors is focused on the vectorization and how to exploit the parallelism by means of these data vectors, small vector or 8 or 16 elements that can be computed in the same instruction. And also the VTune shows us the profiler in terms of how our application are parallelized among the different nodes, and how are the threads executing simultaneously, which are the inefficiencies due to synchronization stages and some blocking due to some block operation between the threads. And the most complete edition is the cluster edition, which includes the Composer and the Professional, and also it is presented for the scalability. So it is focused on cluster tools and evaluate how our application can be run in different type of nodes. So it's evaluating the MPI library and which are the overhead due to these communications, the workload balance also, and it is necessary to use different type of mapping application between whole clusters. So it also will be seen with a cluster checker. Well, in this slide, I will present some of the success of using this Intel Parallel Studio Suite in different areas, from artificial intelligence, use one Google Cloud, which can be obtained 23 times faster the code using this Parallel Studio Suite. There are also links available in the presentation where you can check all these success cases. But it's not only focused in artificial intelligence. You can find another improvements in terms of acceleration in another areas such energy, science, government, IT, and so on. So as all the slides include the different links, if you are really interested, you can click on the link and go to the sample and check if all the ideas can be translated into your development. Well, in this slide, I will present the use of Intel architecture that not only offers better performance in global terms, but also reduce significantly the energy consumption, and also improve on the productivity and execution speeds. Using the Intel Parallel Studio software with Intel architecture, or both combined, allows an increase significantly performance rates. It is possible by means of achieving scalability rates by exploiting the different level of parallelism available in the modern microprocessor. And we can anticipate that these three editions mentioned before, the Composer, the Professional, and the Cluster, can be downloaded and tested with this free trial. I will present the next couple of slides, some figures related with performance rates in order to see what will be the improvements using the compiler, C++, as also in Fortran, in comparison with their competitors. And also if you are using floating point in single precision and double precision. So in this scenario, for example, they are using the benchmark, the specs benchmark, which are very common for benchmarking. And also it's seen that the use of Intel C++ compiler obtain 19% of gain in comparison with another free compiler as GCC or the LLVM. And it is using, for example, integers or floating points. In integers, the performance will be a little bit higher, but all this scenario will be repeated along all the slices. For example, if we are using Fortran compiler in case of using some application that can be automatically parallelized, we can obtain 71% of improvement if we are using the Fortran compiler, the Intel compiler, in comparison with the GNU Fortran compiler or another type of compilers. And for codes that are not auto-parallel, the performance rates varies from 49% in the case of Intel compiler to another's. So the whole idea that I will present is the use of this suite also will be translated in increasing the performance directly with no much effort. Well, in this slide, I try to summarize more or less the three editions that I presented previously. If you would like to contact for more information about your needs and some type of offers and so on, please contact with Danysoft staff, and also can give you what budget depending on your necessities. But in terms of summary, I present here the Composer compiler that is more or less focused on building application. I will present in the next slide how the compilers and also the libraries, optimized libraries, can improve significantly the performance of one application. It will correspond with the most basic edition, the Composer one. If we are moving to the professional edition, it is include also profiling tools that I will mention and deep in the next day, the second day of this workshop. And finally, you would like to test your scalability in a cluster. I encourage you to use the cluster edition, which is the most complete, which includes all the tools and from compilers' point of view to profilers, and also emphasize how will be the scalability when you are using more than one node, and what are the workload balancing and the cost of communication by means of MPI library and so on. As I mentioned before, there are important discounts in Academy, and also it's including floating license. And okay, all this information, I encourage you to contact with Danysoft staff, because can help you, and depending on your necessity, can adapt some of the solutions. Well, as I mentioned before, this slide tries to summarize also the whole gain and speed up obtained using the whole suite in different scenarios, from science, artificial intelligence, life science, and all the rates are very important. They are 35 times faster than application. All the cases are links here, so you can follow the link and deep in the information and try to check if it is interesting to you. So I encourage you again to, if you are interested, to click on the links and read another stories. Intel Parallel Studio license include not only these tools for trying to modernize your code, also includes technical support. Technical support for more than 1 year. And with the purchase of this suite, you can access for other benefits that can be summarized here. First one corresponds with the performance and productivity that more or less I told you in the previous slices. So the architecture, the Intel architecture, the Intel hardware are including more and more benefits inside. So the use of these tools help us to exploit these improvements. And also because you can find out the main bottlenecks and other type of inefficiencies that can be seen in your code. In addition, technical queries with Intel engineering are also available, and you can access to update products and old version, which sometimes is interesting. For example, when you are using the node hardware at Xeon Phi, and you would like to test some of your code, how will be the scalability in this type of architectures if you have one or you have bought one some years ago. So it's sometimes it's interesting to check how will be the scalability in those architectures in order to predict how will be the scalability in the next architecture. So sometimes it's very interesting for not only having the last version of this suite and also previous ones in order to check the results. And finally, I don't want to miss the opportunity to indicate that since a year, you can access for some other resources, hardware resources of Intel for hardware point of view, GPUs, CPUs, and FPGAs, and also all this suite. Well, I will present here more or less in this slide what I was mentioned before. Intel offers many resources from the developer community. There are on one hand some code samples that can be clicked here in the links. And there are also training materials, even some videos and webinars like this that you can check online, or you can check after this webinar have been performed. So also there are some types of examples to check how to modernize applications, and there exist some examples to show profiling tools available in the suite. How is the way to use it? Most information, demos, webinars, sessions like this can be seen following these links. And finally, I would like to tell about the opportunity of having access to remote hardware and software. Sorry again. So now there is a program related with the One API that Intel are promoting in order to modernize your code. So it is available, the access for 3 or 4 months for a cluster, which includes GPUs, CPUs, and FPGAs of Intel, and also the environment of developing with Intel Parallel Studio. So you can check and evaluate your codes and see if it is interesting to buy and to use these tools. So with these live trainings and all, I think it's a complete information. For the webinars, you can follow these links. So there are different type of webinars available, like technical support staff of Intel. I show you here in the slide from One API the use of the compiler and in GPUs or in CPUs, and another information related with this Intel Parallel Studio suite. Well, going back and try to summarize the different editions available in the Intel Parallel Studio. If you remember previously, I told you that there are three different. Oh, sorry again. There are three different editions. The Composer edition, which is focused in building an application. It is based on compilers and also some libraries, which are optimized, exploiting the different parallel levels on the modern microprocessor, such multi-threading, vectorization, and also exploitation the memory hierarchy in a successful way. Also, the professional edition and the cluster edition. I will focus on the first one, and I will going to deep a little bit on the use of the compilers, what are the main novelties in the 2020 version, and also the rest of the libraries which are improved. Well, the compilers are used by the industry and many developers in order to modernize your code. And the processor nowadays increases the number of cores. Also, the vector units width are also increasing, and both of the levels, the parallelism levels, can be exploited by the use of the compilers. So it's improved significantly the performance for all the application, the demanding application from computational finance, simulation, visualization, or another type of application. So among the main improvements that can be found are the exploitation of the different levels, as I mentioned before, from vectorized, and also the thread level parallelism in the multi-core by means of OpenMP. And all these parallelism level will be available by using the Intel compilers. What are the main novelties in the 2020 version of this suite? Well, the first thing that I will like to present is although the version is 2020, the compiler version it is known as 19.1. All the updates are done in the version, and one of the novelty corresponding with the point of view of the compilers is that all the improvements of the architecture are also included. So it is included the improvements from Atom processor focus on the low power requirements to high performance processor on servers such as Xeon. Furthermore, data level parallelism is supported by means of small vectors, I told you before, the threading by using, for example, OpenMP. And this level of parallelism can be expressed in the OpenMP standard, both of the level, SMD and also SMD, including in the architecture of the advanced vector station, and also the multi-threading by means of the classical OpenMP distribution. Between or among the main novelties corresponding with the compiler is the full support of the C++16. Also, it is included partially the OpenMP version 5, which includes the support of offloading code in a GPU, in the Intel GPU. So you can download and offloading some part of the execution of your code directly in the GPU, and it improves the scalability and the portability of the code developed in previous generation and to the next one. And also it is included in terms of vectorization, the new ISA, the new instruction set architecture focus on this intelligence, artificial intelligence instruction, the VNN-AI. Well, today the processor incorporates different levels of parallelism. I was mentioned before, multi-cores, vectors with larger widths, and even coprocessors. Though the advantage of using C++ or Fortran compilers can be solved improving the productivity and the scalability of your solution. The productivity can be done by the supporting of the latest version of the standard, the C++. I was mentioned before, the fully support of C++ 15, and also in Fortran or with OpenMP. The scalability and portability of codes allows the expectation of increasing the performance and the scalability in an architecture with higher numbers of cores. Well, I show you in this couple of slides more or less the performance rates. I was mentioned before using the spec benchmark. I will remark here with the Intel compiler the speed up in terms of 19 or 34 using integers. If we are using floating points or integer, depending of the benchmark that you are using, and also if you are using the Fortran compiler, I saw you before all these figures with the numbers. So I think it's interesting taking into account that if your code is in theory, or the compiler can extract some parallelism through the loops or another type of parallelism based on tax parallelism, the performance rates will be really successfully. So you can think that to try to use directly this compiler and also to check how the performance will be increased only adding the flag of the compiling phase. Well, in this edition, in this Composer edition, it is not only focused on the compilers, also focus on another type of libraries which are also improved. So I will more or less present what are the novelties of these libraries. The first library that I'm going to comment is the Python library. Python is one of the most popular languages nowadays, used in many domains, from HPC, artificial intelligence, web developing, and even more. It provides to developers a tremendous productivity, and it is very easy to learn. However, Python is much slower than other languages or C++, and this is due to Python is an interpret language, a difference of C and C++, which is a compiling language. So the compiling can add some optimization in the compiling phase, like unrolling loops, trying to do a prefetching of data, another type of techniques that improve significantly the performance. However, Python is very used nowadays for a huge community of developers because the application can be developed so quickly. So this overhead between the compiling languages and the interpreted languages is tried to solve by the Intel engineering, because the Intel distribution for Pythons try to reduce this gap from native code to incorporate all the techniques that have been developed with another with another libraries which are improved. So performance is the key on Python in the case of using this library. So you can accelerate most common libraries of Python, which are NumPy and skitlearn. And it is basically because inside this use another type of library developed by Intel that also exploit the different level of parallelism the vectorization, and also the multicores. So the main idea is the performance will be increased by the use of this Python, and also there are some distribution for cloud environments like PySpark. Try to distribute all the computation between the different nodes that also are working relatively well. So in this slide, more or less, I present the numbers and the gain of Python distribution for machine learning library, particularly for this skitlearn library. Among the new features in the 2020 version of part of Intel Parallel Studio, we can find that there are updates in the Python 3.7 version and some improvements in the skitlearn library, which is more or less shown here in terms of the performance and gain using the distribution in the 2020 in comparison with another Python. I would like to indicate that anyone can download a free version of Python separately from Intel Parallel Studio, and it's totally free, so you can download and use it in a straight way and with totally free. So you can check the links also in the previous slide. You can use it directly in your codes. Well, another library that also is optimized by using different level of parallelism inside the library is the Intel Math kernel library, known as MKL, and it's a library optimized for mathematical operations and operations related with linear algebra, thinking in spur and dense algebra, and also includes functionalities to operate for vectors and the generation of random numbers. This library has been used mainly by scientists and engineering, and the use is very similar as BLAS library or LAPACK, which has been widely used. It's shown here. Among the optimization that this library incorporates is the optimization and efficient exploitation of the architecture level through vectorization, multi-core cores, and also addition for exploiting the memory hierarchy using techniques such blocking in caches that improve the reuse of data. In this slide, I will present I present more or less the functionality of this MKL library, focusing the linear algebra with all the packages inside. I told you before, BLAS or LAPACK library, which are very common for scientists. Also, from the Fourier transform, vector, random numbers with vector and vector operations, like is here, vector operation, and another type of operation. Well, what is new, relatively new, in this MKL library in the 2020? Well, so it is improved the BLAS performance with a matrix multiplication if integer, using integer, and taking into account the use of vector capabilities as AVX2 or AVX 512. Also, it is improved the performance of matrix multiplication with single precision when the number of the elements are relatively small. And also, it is enabled in the TBB or in the threading blocks in the thread building blocks library, the use of matrix multiplication with another type of accuracy and precision in 8 bits and assign it or another type. From Scala LAPACK, it is introduced a new Scala LAPACK function in vector and real up quasi-triangular matrix. Related with the random numbers, it is include another algorithm for generation that it is known like skip ahead with this method, with these methods. And in the summary statics, it's improve performance for zoom, variance, covariance, this type of operations, basically. Well, I present here more or less the performance rates using the classical matrix multiplication using double precision and single precision. The use of MQL library compared with others such OpenBlast or Bliss. It is translated in against more than 50% depending on the size of the problem. Well, I will pass through another library that is called APP. It is used for signal and signal processing. And what exactly is this library? Well, this library is an optimized library that tries to exploit the vector and multi-core capabilities of general purpose processor in a transparent way. And it is used basically for 4 groups of application: for signal processing, signal and image processing, data compression, or matrix computation, and cryptographic applications. It has the advantage of using the different data types, 8-bit integer, signed, unsigned, 16, etc. And I will more or less see that inside this library there are a package related with image processing, for signal processing, vector operations, the data compression and cartography, and so on. We can find many cases of use where a great improvements can be seen using this IPP library. The range of application is really wide, from application on servers and cloud services, medical imaging, such as resonance, and also for image refinement or even surveillance. We can find also successfully used in the current applications of computer vision, and particularly in machine vision, which is a hot topic nowadays. And another use can be done in communication scenarios and even in biometrics pattern, which is highly recommendable. In this slide, I show you briefly some of the improvements shown in this library, in the IPP library, particularly using some interpolation, the linear, cubic, and Langkos interpolation. As can be seen here, the speed up is around or up to 3 using the IPP, using this vectorization in comparison with the code with developing C with no optimization. So only by using this library you can obtain 3 times better performance than if you are not using. In the same way, in this slide is presented more or less the performance in compression and decompression of one algorithm, this algorithm in the ZFP. And depending on the data, if there are sparse data, medium data, or dense data, the different performance rates using this IPP library, which goes from 5 in terms of 5, or even 30 or up to 30 in some cases. And now I will present the benefits of using the TBB or the 3D building blocks One of the main advantage of using the TBB is that this library can be seen on a set of patterns writing in C++, and can be used by all the compilers of C++, which inside implements the tax parallelism that allows to the programmer to use all the parallelism available in the processor without specify this parallelism at subprocessor level. It includes the basic patterns based on the common algorithms with primitives for data structure, synchronization, the management of the memory in a scalable way. And TBB use their own library that is executed in the background, and it manages all the details of the subprocessors. So the problems like workload balancing, it is solved transparently. What is new exactly in the 2020? In the 2020, it is new in the TBB that this task parallelism is also available in the NUMA architecture, where the threads or the memory access is not uniform for all the threads. And also it is at this pattern, the STL patterns supported by the C++ 15, which define more or less the flow graph nodes. Well, this is what is inside the library. This library includes the C++ template library, and it includes the flow graph with a graph for all the dependencies between the tags. So can be marked the tags depending on the data dependencies, allowing to use this tags parallelism. Another will be seen in a generic parallel patterns, with patterns with the most classical patterns used in parallel programming. The classic are, for example, parallel for with a mapping operation, or the parallel reduce, or pipeline, or even though for join, or with a parallel invoke sentence. Also, there are parallel STL with this standard template library. And as I told you before, inside the library, all the tags and all the control between the tags can be done transparently from the user. The main advantage related with the TBB is that it is actually supported the Intel GPUs. So as can be seen in the graph, you can divide the different tags, like here marking the dependency between the tags. These green tags depend that these tags have to be finalized. And these tasks can be executing simultaneously between the GPU and the CPU. So this heterogeneous computation, it is supported, and it's transparent to the developer. Well, in this slide, I'm going to present more or less the speed up obtained of using this TBB library, using different type of application, P number, which is more or less a classical parallel for, Sudokus, primes, another type of application that can be exploited tax parallelism. As can be seen, it is relatively close to the ideal speed up, the ideal or the linear speed up. So it's another way to improve your code in an easy way. Well, the last library that I will comment is this machine learning and analytics, which artificial intelligence is a hot topic these days. Deep learning gets most of the classical machine learning techniques and statistical data analytics, and are still deployed more widely and are often used in conjunction with deep learning. Though this library includes highly optimized implementation for the most classical machine learning algorithms and analytics algorithms, and can be exploited from some processor in a low power scenario such Intel Atom, and the most powerful processor such serão systems. So this function spans all the analytics stages, includes data pre-processing, transformation, analysis, modeling, validation, and decision making. And in these slides, in this couple of slices, I will present the main algorithms related with the machine learning, and also which supports the process by batch processing, which is typed in white, and also which are supported distributed processing, which are remarked in yellow. This distributed processing allows to use a cluster, for example, in order to distribute your computation between different nodes, and all this algorithm can be done in parallel in one architecture of cluster type. Well, this is more or less the same slide, but with another type of algorithms which are inside the data analytics in the same way. Some algorithms that can be executed in a batch processing, and another ones who can be done in a batch processing and also in a distributed processing, which is remarked in yellow. So with this slide, I try to summarize with the numbers of performance, taking into account two main stages, training stages and inference stages. And as can be seen, all the results are really successful in terms of speedups. Well, will be exactly the same using the distributed performance in comparison with Apache Spark. So the use of this application of this library, the data analytics library in a distributed way, scale much better than the classical Apache Spark. Well, the rest of presentation will be focused in the professional edition and the cluster edition. But due to the lack of the time that I have, I think the best idea is to go to the final part of the presentation in order to show how will be the flow of modernizing the execution. Because this second part, the professional edition, I will focus the second day of this workshop, trying to, after using a compiler and trying to improve the code. With these tools, we can show and find out some inefficiencies in the code and try to solve it. And scale ones, it is really useful if you would like to use a cluster architecture and checking what are the inefficiencies due to the communication by means of MPI library, and also the workload balancing. And it is interesting to move some of the tasks to another node, depending if you are using a NUMA machine or not. So I will try to summarize this first day in the last slides, as I told you. Well, so this slide is trying to summarize more or less the process of modernizing the code. And I would like to end this presentation of the first section and try to answer some questions. And the question that I'm trying to answer you is when can I use the Intel Parallel Studio suite in order to modernize my code? So the modernization process is an iterative process that allows us to gradually improve the process solution. So we could see as an optimization flow that is shown in the figure, which is based on exploiting the different level of parallelism existing in the current architecture. In the case of not having a cluster, this upper part could be ignored. But the rest of the webinar session, I will focus in this part that correspond of an application that can be efficiently parallelized, first of all, using threads. So it is efficiently the use of the threads. If I can say yes, try to vectorize. If not, I have to optimize and try to create a thread inversion by means of OpenMP or another type of paradigm. So if I have a parallel threading application and it is exploiting the different multi-cores of our processor, we have to focus on the vectorization. If the vectorization it is well done, I have to pass to the next stage that is focused on the memory exploitation. And considering if this memory hierarchy it is well used or is necessary to optimize the bandwidth. So all this process can be seen in relation with the SAN application that it is included in the Parallel Studio. If we are focusing in a node, as I told you, checking if our application can be parallelized by a multi-threading, it can be seen by the VTune profiler that I showed you in the second day and the third day. If the code are well threading, I have to focus on the vectorization. For the vectorization, I'm going to evaluate the Intel Advisor tools that show possible bottlenecks of our solution. And finally, if the analysis and the vectorization is done in a well way, I'm going to check the memory hierarchy by means of the VTune. Aspects related with the VTune and are also shown in the second and third day. And in the case of using cluster, issues related with low unbalancing, the overhead related with the communication can be evaluated with the Intel Trace Analyzer and also the collector, and checking in if the MPI library is well optimized. And finally, another tools from the Intel Parallel Studio that we can use in this optimization flow are the MPI libraries and benchmark for trying to tune the MPI library to check if we need higher messages or increase the latency. Also, for vectorization and parallelization issues, we can use the optimized libraries that I commented during this day that are really optimized in terms of the exploitation of vector and multi-core capabilities. For cluster systems, the MPI library is the main protagonist. So we can evaluate some configuration in order to select which are the most suitable. And that's all. I would like to end with this slide with the added value of Danysoft related with the Iberian Peninsula and how can provide more information about these suites and other technical seminars and so on. That's all for me. And if you have any question, I'm very grateful for your attention, and I can answer through the way that you answer. Thank you very much.
Ora, então, muito obrigada, Carlos. Thank you, Carlos. Muito obrigados a todos os presentes, e alguma questão, dúvidas sobre o produto em si, questões de valores, podem sempre entrar em contacto com a Danysoft. Muito obrigada pela vossa disponibilidade.
Is there any question or? ¿Alguna pregunta?
No, I don't think so. Alguma pergunta que queiram fazer ao colega?
Tá bom.
No, Carlos, I don't think so.
Tá bom.
Muito obrigada a todos.
Muito obrigado a vocês. Es un placer para mí estar con vocês. Si tienen alguna otra pregunta o querem falar depois comigo, eu posso fazer.
Muito obrigada a todos mais uma vez, e o resto de um bom dia.
Bom dia, tudo bom.